Hello friends, in this video I am going to discuss about resonance. Okay, so to begin with, let me draw the Lewis structure of one ion. Let's take carbonate ion. Okay, so you have studied about rules for drawing Lewis structure of a particular compound or ion. So first what we do, we calculate first total number of valence electrons. So if we take total valence electron here, then for carbon it is 4. For oxygen, total number of valence electron is 6. So we have 3 oxygen atoms, and then we add 2 electrons since we have 2 negative charge on this. So total, if you calculate, it will be 18, 24, right? Now the next step in drawing Lewis structure is deciding central atom. So here central atom is carbon and outer atoms are oxygen, and there will be at least 2 electrons between each oxygen atom and carbon atom. Okay, so you have at least one bond between each carbon and oxygen atom. So 6 electrons are distributed now, so we are left with 18 more electrons. So we will satisfy the octet of each outer atom. So we will place 6 electrons on each oxygen. Now the octet of every outer atom is completed. But if you see, this carbon has only 6 electrons, 2 plus 2 plus 2. So to complete octet of the central atom, we need to move one lone pair from any oxygen atom to form a pi bond. So basically, if you do that, then you will get this structure. And this oxygen atom will have now 4 electrons or 2 lone pairs, you can say. These 2 oxygen will have 3 lone pairs. And if you calculate formal charge, then you will get formal charge minus 1, and sorry, not minus 1 on this. Uh, you will have 0 charge here, minus 1 here, and minus 1 here. So this is the structure of carbonate ion, and just to simplify this, I'll draw this structure. Okay, not showing all electrons. So now this is a valid Lewis structure of carbonate ion. But the problem is that this structure is not consistent with all experimental evidences about the structures of carbonate ion we have. So what is the problem here? That if I draw this as Lewis structure of carbonate ion, I can draw one more, and I can say that this is the Lewis structure, not this, this. So both are valid, right? Or I can say that this is the Lewis structure of carbonate ion. Okay, so basically we are able to draw more than one Lewis structure of carbonate ion. See, now you can say that these all three structures are similar. Okay, so yes, they are similar, they are equivalent, but they are not identical. Okay, because if I mark all these oxygen atoms, suppose this is oxygen atom 1, 2, 3, 1, 2, 3, 1, 2, and 3, right? So I cannot exactly say that what is the bond between carbon and oxygen 1, oxygen number 1, because in the first structure we have uh, double bond, in second structure we have single bond, in third structure single bond. So basically we have different placement of double bond in these three different structures. They are equivalent but they are not identical. And experimentally it was found that all carbon oxygen bonds are same. Experimentally all CO bonds are same. Fine. Which cannot this cannot be explained by any of these three structures. Okay. So what we say that the actual structure is basically actual structure the hybrid is the hybrid of all Lewis all Lewis structure. Okay. So here comes resonance into the picture. So whenever we have more than one Lewis structure of a particular compound or ion, then actual bonding is explained by resonance. Okay. And these all valid Lewis structures are called canonical structure, or you can say resonating structure. So all Lewis structures are basically resonating structures. Okay. So this actual structure is the hybrid of all Lewis structure. Okay. So let me draw the hybrid of all Lewis structures. So if you take carbon, then you have oxygen, oxygen, oxygen here. Now the bond between carbon and each oxygen will not be double bond or single bond, because if you take the average of bond, then it will be more than 1 and less than 2. So if you see the bond order here between this carbon and oxygen number 1, it will be 2 plus 1 here plus 1 here and then 3. So it is basically 4 by 3. So bond order is basically 4 by 3. This is your bond order. So which is greater than 4 and less than 2. So you will have partial double bond between all carbon oxygen. And then if I calculate charge on all oxygen atom, so it will be minus 2 by 3, minus 2 by 3 and minus 2 by 3. Okay, so which is average 0 minus 1 minus 1. So 0 minus 1 divided by 3. So basically minus 2 by 3. Now in this actual structure, which is hybrid, all carbon oxygen bond order same, all bonds are same. So now this is consistent with experimental data. So now we can conclude here that resonance is observed when we have uh, more than one Lewis structure, or more than one Lewis structure is needed to describe the electronic distribution in a molecule.